it's over corresponding parts of different shapes. So starting with your pre-image and your image, how do they correspond? Are they similar or congruent? Okay, so we are roughly about here, depending on which class you are. We may or may not have answered number 5. But we're going to think back to why all of the road signs are congruent. So when you think about how when we created all of these new locations for these images, why are they still congruent, meaning same size, same shape? Who can tell me? Why are they congruent? What didn't we do to these shapes?
Change the size.
Alana, yeah, we did not dilate, right? So they are congruent because we did not dilate them. We didn't change the size. Right? The sizes all stayed the same. We just changed where they were. So that didn't affect anything. So now, of course, what we're going to do is we are going to dilate the stop sign. So the stop sign was in quadrant 2. Where did we do? There we go. So we're going to take our pre-image coordinates, just like we've been doing in the past, and then we're going to dilate them by a scale factor of 1/2. So what does that mean? What am I going to do to each of the numbers if my scale factor is 1/2? Remember the potions thing, Kyson? Half the size. We're multiplying times 1/2, right? So is it going to be an enlargement or a reduction? Reduction. Kyson, I need you to put your mask up for me, please. Okay, so let's go ahead and refresh our memories what these coordinates were. -4, 8. These are the pre-image coordinates because they said to go to the original quadrant 2. -2, 6. -2, 3. -4, 1. -7, 1. -9, 3, -9, 6, and -7, 8. So we're going to dilate them by a scale factor of 1/2. So does the positive or negative change when we dilate? They don't change at all. All we're changing is the value of the number when we dilate them, right? So what will my image coordinate be for this first point? -2, 4. Then I would have -1, 3, because I'm taking half of these pre-images. -1, 1.5, which we'll just estimate where the halves are. -2, 0.5. -3.5, 0.5. -4.5, 1.5. -4.5, 3. And -3.5, 4. So again, we're just going to have to estimate where those halves are on this coordinate plane. So -2, 4. -1, 3. It's going to be a really tiny one. -1, 1.5. -2, 0.5. -3.5, 0.5. -4.5, 1.5. Look at this teeny tiny little stop sign. -4.5, 3. And -3.5, 4. And then we connect them, and we just have a tiny little stop sign, right? So when you're estimating, just do the best you can, right? As long as it's close and I can tell that you knew what you were supposed to do. I'll especially know because I'll see the image coordinates here. I'll know you knew exactly what to do. So this says the new stop sign graphed in item 6 is similar to the stop sign's pre-image. Explain why it's now considered similar. Why can't we say congruent? Right. The size changed because we dilated it. So the big take home from this is, as soon as you dilate, you no longer have congruent shapes. You just have similar shapes. Okay, this last one requires us to kind of look at a few different things at the same time. So I'm going to use my pre-image and image as best I can. It says a combination of transformations was performed, right? We had a compound transformation. In that compound transformation, we did a rotation and then a reflection. They want to know if we had done a reflection and then a rotation, would the sign still be in the same place? So let's look here. So here's my pre-images, here's my images. So quadrant, which one was that? Was that our, that was our triangle one, right? So what we did here is we did a rotation and then a reflection. If we had done a reflection and then a 90-degree counterclockwise rotation, so if we'd done a reflection and then 90 degrees, would we have ended up in the same place? What do you guys think? If we had reflected it over the X and then rotated it backwards, would it still be the same? It sure would. Wait, that's not right. Hold on. Let's look at this. If I reflected it this way, right, and then rotated it counterclockwise, wouldn't I be back up here in quadrant 1? Right, because it was counterclockwise. It's not going to be in the same place. It's going to be back up in quadrant 1. How sad for that. So our answer is no. It would end back up in quadrant 1. It would be a different shape. It would be turning to the side because we rotated it, but it would still be in the same quadrant. Tricky, tricky. All right, you guys got your color pencils or something to color with ready to go? Coming around with our next transformation adventure. If you need to sharpen your colored pencils, by all means use the sharpener. It works on colored pencils. I'm not sad about that.
Yeah.
Your puppies ever get like gunk in their ears? I think ours might have an ear infection. It's got some pretty yucky stuff in its ears. Like real yucky. Just one of them. I'll give you your paper back in a second. Did everybody get a new packet? If you don't have colored pencils, I mean, you don't need them for a super long time, so you could potentially share them with a neighbor.
What colors do you have?
I have red, yellow, orange, green, purple, and light blue, because the purple and the blue kind of look alike sometimes. Okay. here we go. Geometric transformations, corresponding parts. So corresponding means it matches the pre-image location of the letter matches the image location of the letter. And so we're trying to decide, are they congruent or similar or nothing? Okay, so we're going to work our way through these 4 problems. They're not crazy difficult. It's just I needed a lot of space for each one. So that's why you have 4 pages of a packet. All right, so we have 2 pentagons. I know this doesn't look like your typical pentagon, but what does pentagon actually mean? 5 sides. So even though it's kind of a weird looking pentagon, it's still a pentagon. And they're telling us that HIJK is translated to the right and up to obtain RSTUV. What you really need to focus on here is, do you see how these letters are in order and these letters are in order? They're in that order for a reason. Okay, the H corresponds to the R. So what we're going to do is color H and R the same color because they are in the same place when they are listed, so they correspond. I corresponds to S because, again, they're in the same order. J corresponds to T. So I've got orange, yellow, red. K corresponds to U. And L corresponds to V. And I know that because of the order that the letters are given to me. That's a huge component of geometry next year. Just saying. The order matters. Okay, so we're just going to now answer questions about the different sides of these pentagons. This symbol here means is congruent. Is congruent to. Remember, congruent means, yes?
Do you have a pencil?
I'm running low, guys. This is it for the rest of the year. We still have 30 days. I need to update my thing up here. 30 days. That includes weekends. Okay. So let's answer some questions. And as we start answering these, I know it's going to start clicking for you guys. Like, this is so easy. All right. If we have HL, so that's orange to blue, which side of the image pentagon is that congruent to? RV. And I have to say RV because the H corresponds to the R, and that's first. And I have to say V because the L corresponds to the V. So the way I write my answer has to be in a particular order, right? So if it goes orange-blue, I have to do orange-blue. Let's look at B. Angle S is congruent to which angle on the pre-image? I. Do you guys see how easy this is? All right, how about UV? I've got green to blue, KL. And you have to put that little line above it. That indicates that it's a line segment. This is the angle symbol. Did you guys know that? That little like thing that looks like an angle? That's our angle symbol. All right, how about angle J? What is it congruent to? T. I told you guys you'd pick this up real fast. IJ is congruent to ST. Good. How about angle V? L. TU is congruent to JK. H is congruent to R. How do we feel about this?
Good.
Not bad, right? Are you color-coded over there, Gracie?
Yeah.
Okay. Everybody's color-coded. Lucy, are you color-coded? Oh, I see what you did there. Okay, would you like some crayons, or are you okay with the shapes? Okay, great. If you're not color-coded, you're making it difficult on yourself. coded on there? Okay, all right. Okay. Now, let's look at, do you guys know what this little symbol means? The two lines next to each other? You know what that means? What do they look like?
The normal
Parallel lines. Good. Parallel lines. So they're saying that HI, that's the orange ones, is parallel to JK. Perfect. So RS is parallel to RS is parallel to, you're going to have to say TU because they did JK, they went red orange, so you have to do, I'm sorry, red green, so you have to do red green. Right? So you'd say TU. This word given here, you're going to be like, that's like basically geometry. They give you a situation, you have to prove why it's true or not true. They're called proofs. You're going to love them or hate them. There's no in between. Okay, pentagon HIJKL is congruent to pentagon. Yep, and you got to go in that order because that's the order that it's given. And that's the order that the colors match up. How are we feeling? Decent? Let's go on to the next page. So now we have a reflection. We have a hexagon. That's the six-sided figure, right? This one's slightly more difficult to color code because the reflection kind of puts things in weird places, right? So I'm going to first do A, B, C, D, E, F. And then we'll evaluate what are the corresponding parts of the reflection of the image. If you can't see what the corresponding parts are, remember you can look at the letters that are provided and the order that they're given are the corresponding parts. So my first letter here is A. That corresponds to K. So I'm going to color the K the same. Again, some of you can probably see, well, those are a reflection of each other. But if you have a hard time seeing that, you can always count on the letters given. So B corresponds to L. Do you guys see what I'm talking about there with the letters matching up? Yeah? All right, so let's answer some questions about these. Segment KL is congruent to what? AB. Good. Angle D is congruent to N. EF is congruent to OP. Good. You guys putting those little lines above?
Yeah.
Okay. Angle M is congruent to angle C. If the length of AF is 3 units, what's the length of KP? 3 units. And we know that because we didn't change the size, right? We didn't dilate anything, we just reflected it. If the measure of angle P, so if this measures 94 degrees, What is the measure of angle F? It also has to be 94 degrees because they are congruent. If LM is 7 units, what else is 7 units? BC. You guys are doing a great job listing them in the correct order, the corresponding orders. If angle E is 138 degrees, what other angle must be 138 degrees? O. All right, how about perimeter and area? Are those going to change? Nope. So our perimeter is going to be the same, and our area is going to be the same. Again, we didn't change the sizes, so that's why. Okay, let's turn to question 3. Is anybody still working on question 2? Question 3, we have a rotation. Rotations can get confusing when you're trying to find your corresponding parts and color coding. So what can I use as a backup if I can't see it? The letters. So if A is orange, what else is going to be orange? D. If B is yellow, what else is yellow? E. And if C is red, what else is red? F. Do you guys want to answer these on your own and we'll compare answers? Okay. I'm going to freeze the screen. At-home viewers would now freeze their video because I can't change that. You guys ready to compare? How are we doing on corresponding parts? Yes, did I make a mistake? I'm sorry? That's a 3. Yeah, it's just a really fast 3. Thank you. There we go. Well, now it just looks weird. questions? All right, last one. See, you guys are good at this. Now, I guess there's two more, but last page. There's some weird lines happening on this page. I don't know what they are and why they're there, so we're just going to ignore these random lines over here. Just ignore them. Okay, so now we have a dilation. Yikes. We have ABCD is dilated by a scale factor of 1.5 to obtain FGHIJ. So let's go ahead and color code here. And again, we know the letters that match up because they're given to us, and also it's pretty easy to see. All right, so here we go. We have AB is proportional. This is like a ratio, right? We're no longer using congruent because it's not congruent because we changed the size. Is there someone at the door, Grant? So we can't use that congruent symbol. Instead, we're going to use a fraction to show that these are proportional, right? They're in the same place, but they're just not the same size. So if AB is proportional to FG, then what is proportional to GH? BC. Good. How about angle D? What is that going to be congruent to? When you change the size of things, it doesn't change the angle measures. Just because it's shrunk down, this location here is still the same angle measure as this one. It doesn't change the angle measure. It just changes the length of the sides that attach to make that angle. So that's why we can still use congruent here. Okay, AB is congruent to FG, then AE is congruent to what? FJ. I don't know what they want us to do. I don't know. This is weird. I'm just going to put FJ with a little line above it. The spacing definitely got messed up. Okay, how about angle H? What is it congruent to? C. All right, we have AB is proportional to FG again. So which side is proportional to DE? IJ. Which angle is congruent to J? E. All right. Which side is proportional to CD? HI. Which angle is congruent to angle A? F. Good. And then this is where we can't use the congruent symbol. We have this one little squiggle, and that means is similar to. Same shape, different size. Okay, number 5 is kind of a doozy because we don't have a picture. Luckily, we've been practicing how the letters match up in the order that they're given. So let's color code just these letters. So A is going to color code with W. B is going to color code with X. C is going to color code with Y. And D is going to color code with Z. Kind of looks clustery, but we can still tell, right? So we're now going to circle what is true. So of these statements here, which ones are true based on the color coding we did and what we know, right? First of all, are these two shapes congruent or similar? Did we change the size? No. So are they congruent or similar? They're gonna be congruent, right? Because we didn't change the size. All we changed is the location, right? So trapezoid ABCD is congruent to those? Yep, that is true. Didn't change the size. How about, is AB congruent to YZ? Do those have the same colors? They do not, right? So colors don't match. How about angle B and angle X? Are they the same colors? They sure are. They're both yellow. So we're writing our little reminders and notes of to why we decided it was true or not. If CD is 4 units, then YZ is 4 units. True or false? True. Same colors and order. If angle D equals 115 degrees, angle Z does not equal 115 degrees. This means does not. True or false? False, because angle Z does equal. So angle Z does equal 115 degrees. That was a tricky one. Got to pay attention to those symbols, right? You guys know that this means does not equal.
I did not know.
Yep, so it's like, nope, that does not equal that. We're learning multiple things today. If AB is parallel to CD, WX is parallel to WZ. True or false? False. Why?
Because WX and WZ.
It should be YZ, not WZ, right? Okay. Should be YZ. Do the trapezoids have the same perimeters? They sure do. We didn't change the size. Do they have the same areas? Absolutely.
No, it says do.
Oh, do not. Thank you. So that would be a false. Did not. No dilation. And then no dilation. Double underline the word do not so you don't make the same mistake I did. Questions? How are we feeling about corresponding? What do you absolutely need to be successful?
Colors.
Colored pencils. All right. On the quiz, you're going to need colored pencils when we take the quiz. If you borrowed a pencil, put it up on the ledge for me.